Hello students, let's look at arithmetic and relational operators in Python. So I'm just going to create a triple string which allows me to put a sort of big comment in, if you like. So arithmetic operators, which I briefly touched upon in the first sort of introductory video. We've got plus and minus, which is that dash next to the zero, asterisk, which is the times, and forward slash, which is divide. But we've also got some special ones. We've got the percentage sign, which it doesn't do anything to do with percentage. It's called the modulus. Two forward slashes, which is floor division or quotient, and two asterisks, which are indices or exponentials. So let me just write those in there. Am I typing it right? Let's exponentiation. I think that's the correct term for it. Hopefully I spelled that right. Or indices. Okay, another term for it. Floor division. Or you could say quotient. And what that does is rounds division down. So I'll show you an example of how all these work in a second. Modulus, because these are not on your calculator or they might be buried away. Modulus and division. And obviously multiplication. Okay, so pretty straightforward. Subtraction. I think you know what that is. And addition. Okay. And then those are arithmetic operators. Okay, those are our arithmetic operators, but we also have relational operators. Okay, relational operators are where we compare like two things together. So when you have two equal signs, that is the same in English as essentially equal to or does equal. And you can also do exclamation mark equals, which is does not equal to or does not equal to. Okay, and then you have less than, greater than, and if you want to do less than or equal to, you put there. Okay, and greater than or equal to is that. So we're using those relational operators, you can create some pretty interesting logical statements. So let's practice some of these things, because I know a few of them look a bit strange to you. Let's look at modulus. So if I just make some print statements to keep this simple, if I do 17 modulo 3, it's going to be giving me the remainder of a division. So it returns the remainder when one integer whole number is divided by another. All right. So let's have a look at what it gives us. So I'll just clear this console. Run it again. It gives me 2. Why does it give me 2? Well, 5 can go into 17 3 times, and there's 2 left over. So that gives me the 2. So I'll put a little comment in here. Remainder is 2. Did I spell that right? I think you get the idea. And then if I put, for example, 16 modulo 3, I expect the remainder to be 1 now. There it is, 1. And finally, if I did 15 modulo 3, well, I would expect it to probably be 0, because there are no remainders for that division. 5 times 3 is 15. 15 times divided by 3 has no remainders. Okay, so that's how the modulo works, and it's surprisingly useful for finding, well, it can be useful for finding even or odd numbers. So if I've got a variable, let's say num equals 9, and then if I wanted to check, and this is just going slightly ahead in our journey, I'm using an if statement. If number modulo 2 does equal 0, I then know that what I've got is even. So I can say num is even. So let me just clear the console so it's easier to see what's going on. Let me just comment these out, please. Okay, if num modulo 2 does equal 0, else print odd. Okay. So what I've got there is just a little check to see if my number divided by 2 has no remainders, then I know it's even. In this case, 9 doesn't satisfy that first one. So I have then this else statement which says print odd. So it's an odd number. Let me just change that. So if I changed num to, I don't know, 12, it would say 12 is even. So that's just a little jump ahead to using selections, just as a practical example of how we could use the modulus to check if a number is odd or even, which is particularly useful in many, many, many scenarios. So let's have a look at the floor division here. Floor division, if I print, I'm just going to wrap these in quotes so they're not going to run anymore. This is a little trick I do using triple quoted strings. Kind of just makes a giant comment out of them. If I print 7 floor division 2, and let's do a normal division above it, 7 divided by 2. I'd expect 7 divided by 2, I'd expect this to be 3.5. Floor div, or truncating is sometimes known, truncating. So let me just clear the console. What have I got? 3.5 and 3. So 7, 2 forward slashes 2 gets rid of the decimal point and rounds down to the nearest number. So you can get rid of that 0.5. So, so it just gives you 3. Okay, so that's how floor division is surprisingly useful. For example, if you're trying to find how many seconds might be in an hour or in a minute, if you've got a whole load of minutes from a race or a movie runtime, and you wanted to find out how many total minutes they might be, you can start using floor division to do lots of useful things like that. So those modulus and floor division are surprisingly useful. Let's do exponential. So it's pretty straightforward. Let's show you something more interesting with exponential as well. So if I did 3 to the power of 2, 3 squared, I would expect that to be 9. There it is, 9. But I can do something interesting with this. Let's say I do 9 to the power of 0.5. What would that be? Well, that I expect would give me 3. Power of 0.5 is square root. So that's the same as doing a square root. So another way of doing square roots, which is just a little bit beyond the scope of this particular video, is to import math, and then you can use the math module to do square roots. But in this case, if you don't have availability of the math module, or you just wanted to keep it really simple, you can do to the power of 0.5. So exponentials are quite easy to do. They just do the 2 asterisks, and then we're pretty much done. Now let's start looking at this idea of logical operators. So I'm just going to make a little comment here. Sequence, selection, iteration are the building blocks of high-level programming. High-level programming is what Python is, and even higher level than that is Scratch, block-based coding. Lowest level languages are machine code, which is binary, and slightly above that, which is still very low level languages, assembly language, which are very directly related to the hardware of the computer and difficult to write. In the case of machine code, there's no way you're deciphering what that is. Assembly code is written in English. So we have higher level languages like Python to make things easiest for us, but all of those are going to be using sequences, selections, making choices, which we'll look at in another video, and iteration, which is the idea of looping things. And essentially there are 2 different ways to loop things, using for and while loops, and we'll do different exercises on those in different videos, but that's at the heart of all control structures. Okay, so I'll put here control structure in Python, and pretty much and you know, all other languages as well. We have a combination of those 3 things for all the algorithms that we do. And in selection, we use something called relational operators and what we call Boolean expressions. And Boolean expressions are and, or, and not. And we can start building up very logical statements using and, or, and not, and combining things, which can be super duper useful sometimes. So we can make statements like print, I don't know, let's say James does not equal lowercase James. I'm just going to comment these out for a second. And that is a true statement. You see there at the bottom, if I just clear the console, run it again, it's just a true statement. So saying that string with a big uppercase J does not equal the string with lowercase j is a true statement. Now, if I change that to a big J, to say that those are not the same is a false statement. So that's why it tells me, oh, that's false. That's not something that we can accept. So I've got a false statement there. What else could I have? I could say 1 is less than equal to 4. Let's print these out. Well, let's just let's put them in brackets. 1 is less than or equal to 4. That's true, isn't it? 1 is less than or equal to 4. And then I can use something called a Boolean expression here. I can use and. And I could say, all right, 7 is less than or equal to 7. So it is less than or equal to 7 because it equals 7. So this statement that I've just put in should be a true statement. There it is at the bottom. It says true. There we go. True. It's a true statement. But if I did something like this, if I change that to 8, it's now become a false statement. Why is that false? Well, for Boolean expressions to work, you need to understand something about truth tables. So I'm just going to quickly make a truth table. So for and these are all related to electronic gates that really exist, that make up how your computer logic circuits work. So and you could have, say you've got 2 inputs, A and B, and then you've got, I know, say output, and then or you could have A, B, output, and not, I can have A, and we'll talk about not in a second. Then what can I have here? I can have 0, 0, 0 or 1, 1 or 0, or 1 or 1. And it should be noted that, I'll write it above here, 0 equals false and 1 equals true. 1 equals true. And this is to do with the fact that logic gates have either voltage applied to them or voltage not applied to them. If there's no voltage, that's 0, or voltage is 1. So I've got 2 options here, 0 or 0. The output for an AND gate would be 0. 0 or 1 is also 0. I need both of them to be true, both of them to be 1 for the output to be 1. So in my print statement, I need both of these expressions to be 1 or true for the whole expression to be true. And for OR, it's a similar situation. I'll just copy this to make it a bit easier for myself. OR works a little bit differently. I need 1 or the other to be true. That's how I remember it. 1 or the other to be true for the output to be true. So 0 or 0 is going to be 0, but I've got a 1 here on one of the sides, so it's going to be 1. I just need one side to be true. And here, both sides are true, so I got the output as 1. So if I change this to, well, let me just keep that one there, copy it and put it underneath. I'll change that to 7, and then if I change that to OR, what did I check? I'll keep that 8. I'll keep that 8, so it's a false expression. So the first one with the AND is false because one of the sides is not true, and the one underneath it should be true because I only need one. I only need one of the sides to equate to true for the whole statement to equate to true. So 1 is less than or equal to 4, and that's true. 8 is not less than or equal to 7, but it doesn't matter because I've got one side of them true already. So if I change that to something like 6, then I do get a false, because for the OR logic gate to be output false, both of them have to be false. Not is a negator. So if my not is 0, you only have one input to that. The output is going to be 1. It's just do the opposite. So if the input's 1, output 0. So I can do all sorts of tricks with this by combining statements, logical statements. I could say, let me wrap all of those here in brackets, and I could say not. Ooh. Let's see what's going on here. I need another bracket there. So not false is true. Let me just clear that so it's easier to see. False and true. So even though 6 is not less than or equal to 4, or 8 is not less than or equal to 7, I can just change the output by making the opposite of it, by using not. And then finally creating a true statement. You might be thinking, why would you want to do that? But there are lots of reasons why you want to combine logical operators. You may have all sorts of complicated mechanisms that you need. For example, maybe there's certain sales taxes that need to be applied, or customer charges that need to be applied, or corkage, or the bill might have to be created in a certain way depending on the type of customer. Lots of exceptions and things like that. So let's just do one other example. Oh, and also I can do something like this if, let's say, flag equals true. So I've got a variable that I initialize called flag, and I make it true, a Boolean value. And then if I have an if statement, if flag does equal true, which it does, then I can do something, right? Rather than just saying that, what I can do, I can just say if flag. That's the same as saying if true. So that's a little trick. So just put up these in the comments so they don't get run. Let's have a look at an example. So let's say A equals 5, B equals 2 times A, right? And then I've got C equals A plus B. And then I can say something like this. If A does equal B, or B is less than or equal to C, colon, print, so I'm just going to print string true, else print false. So what's going to happen? So A is 5, B is 2 times 5, which is 10. So does 5 equal 10? No. So that first part is false. Or is 10 less than or equal to C? So C is 15 because it's 5 plus 10. And that's true. So it will give me a true output. If I run this, there it is, true. So hopefully that's given you a little bit of a crash course in logic gates, arithmetic and relational operators, and how they might be combined to make statements which are either true or false. I think we've covered everything there. Good.